My name is Andy Conlin, and I'm the Assistant Outreach Specialist for Colorado State University's COMET-Farm team under the leadership of Dr. Keith Poston. This is an intro presentation for carbon sequestration, greenhouse gas emissions related to agriculture, and an introduction to tools for conservation planning and greenhouse gas mitigation in agriculture, more specifically COMET-Farm and COMET-Planner tools. COMET-Farm is a little bit more complicated than COMET-Planner, so we'll spend most of our time on that. And I'll preface this presentation by saying that I am not a soil agronomist, so if there are any questions that I cannot answer, I'll write them down and ask some of the experts on the team and get back to you. As I proceed, feel free to drop some questions in the chat. Otherwise, there will be a few times that I'm able to pause and question. I'm presenting on behalf of my team here on the left. We also want to extend a special thanks to the NRCS and USDA Climate Change Office for their continued support in funding and the development of the COMET-Tools. A brief history of the tools. The USDA Climate Change Office and NRCS took things beyond the 2006 IPCC methods and developed the Blue Book or methods document that you'll see in a few slides. And these define the equations, methods, and models to quantify the agricultural emissions related to conservation methods within agriculture. And COMET-Tools were created in parallel with and as a function of that Blue Book, which you'll see in a few slides. Since COMET-Farm launched in 2015, we've seen over 10,000 users of COMET-Farm and over 36,000 sessions of COMET-Planner since 2017. Because users can't create an account in COMET-Planner, we can only measure the number of sessions rather than users. And users can vary from farmers and ranchers to planners to higher ed groups, businesses, and I'll show a few that we can mention. Some of these users are featured in our COMET quarterly newsletter when they've offered to share how they use the tool. Some examples are Shelburne Farms in Vermont, American Farmland Trust, Carbon Cycle Institute, just to name a few. We actually just came out with our June quarterly newsletter last week, so you can check that out on our social media. And the newsletters also tend to feature major updates to the tools or tips and tricks on how to use the tool. And when we dive into our demo, I'll show you exactly where you can access this. As a nexus for greenhouse gas mitigation in agriculture, COMET is used by various federal and state level programs, as well as private carbon markets such as NORI, who access the tool via the API and their own interface. A quick note on carbon markets. COMET itself is entirely independent of the carbon markets and does not advise on credits nor answer questions in regards to carbon credits. It's solely an estimation tool. So questions about carbon markets should be directed to carbon markets. In terms of federal level programs, we are and will be seeing an uptick in users who plan to use the COMET tools for their partnerships for climate smart commodities projects. So if that's applicable to anyone on this call, I'll include a link to a survey in my follow-up email, and that survey will help the COMET team support the influx of new users. Both the COMET-Farm and Planner tools are web-based greenhouse gas inventory tools for land-based systems and designed for conservation scenario analysis. So we include a before or baseline period and then a change in management to compare to. You can access the tools through the URLs on this slide, but I'll also show you how to navigate to COMET-Planner through COMET-Farm. In 2017-2018, the COMET-Planner tool was created as a simpler tool for regional assessments to visualize general benefits at the regional scale by county, and we'll dive deeper into the differences throughout the presentation. But first, let's take a look at what COMET tools are actually assessing. Soil-related emissions are calculated through the DECENT model, which I'll talk in more detail about in a few slides. In September of 2022, we switched from the 20 centimeter to 30 centimeter descent model to align with the national inventory. So we're looking at the top 30 centimeters of soil. In this example, we can see that a conversion from intensive to no-till on 60 acres of corn soy rotation in central Iowa equates to an estimated reduction of 52 metric tons of CO2 equivalent emissions annually. And that's the equivalent to removing the emissions from 11 passenger vehicles for a whole year. The COMET tool is designed to do an entire greenhouse gas inventory within a defined entity. So we're looking at a farm gate or however you define your fields. We are not looking at any upstream or downstream emissions. So manufacturing or transportation emissions will not be included. We are also focused on 3 main greenhouse gases associated with agriculture: carbon dioxide, methane, and nitrous oxide. The infographic that you see on this slide was created by a colleague of mine, Amy Swan, as an introduction to into the 2007 IPCC assessment. Within that diagram, you can see various sources releasing emissions and sinks taking in emissions of each of these gases, and each arrow on this infographic will correspond to the outputs that we'll see on the COMET-Farm report, with the exception of rice methane, which rice accounting is not currently available in the tool. So the COMET-Farm tool is a modeling platform that implements more than 40 different USDA sanctioned methods and models. The COMET tools were developed in parallel with and as a function of the Blue Book document that you see here. It implements a set of computer models that simulate all the greenhouse gas emissions that have been emitted within a defined entity, from manure to fertilizer, burning, and other management practices. Soil-related emissions are calculated through the descent model. And like I mentioned, we switched from the 20 centimeter to the 30 centimeter model to align with the national inventory. Accounting for animal agriculture is also available, and different livestock have different empirical models associated with them, as well as forestry and agroforestry systems. COMET also has an energy tool to estimate fuel-related emission reductions, but these will not be linked to your COMET-Farm account, nor will it be linked to any of your projects. So if you want to include any fuel-related emissions, you can use COMET Energy. Again, the COMET tools are not a life cycle analysis tool, so upstream or downstream emissions associated with management are not going to be included. So using COMET Energy for things like fuel-related reductions, we would suggest using COMET Energy in conjunction with COMET-Farm, or similar energy calculators are out there to use in conjunction. Again, lastly, all of these methods are defined in the USDA's quantifying greenhouse gas fluxes in agriculture and forestry. And I'll show you where that's available on the USDA website when we jump into the tool. But before we do that, I wanted to say that the USDA just released the new edition of this Blue Book methods document for public comment. I can include that in the email link, but if there's feedback on methods or something that you want to be included, it's open until, I think it's July 10th right now, open to public comment. So I'll remind you guys of that again a little bit later. To break it down even simpler, the tools are built around conservation scenario analysis. COMET-Farm gives the user the ability to input farm or field specific historical management practices and baseline data, so what you want to compare new practices to, and then superimposes potential conservation practices defined by the user in scenarios, where you can adjust things like your tillage, fertilizer, or burning events to compare the benefits relative to the baseline or your business as usual. In COMET-Planner, you're still adding some kind of change in management, but you're selecting from a list of NRCS practice standards to compare to a fixed baseline. So users can't change their baseline, rather they select from a set of baselines. In COMET-Farm, you can compare emissions, looking at what the emissions would be if you continued with your current management versus continuing with your future management. Whereas COMET-Planner is just, as the name suggests, a planning tool. It pulls from regional averages to get a broad description of the practice benefit from adding that conservation practice. To compare the tools just a little bit further, because users can enter a flexible baseline with the exact management within the limits of COMET-Farm, users can generate a detailed farm to field specific conservation scenario analysis in COMET-Farm. On the other hand, COMET-Planner provides regional average estimates tied to conservation practice adoptions based on a fixed baseline, which I'll show you how that's generated in a few slides. Due to the details users need to provide, COMET-Farm does require more time investment for entering details, and then depending on the size of the project, it can take a few minutes to generate a report. COMET-Planner, on the other hand, only takes 4 clicks and generates on-the-fly results when users select a conservation scenario and then the acreage that it's being applied to. Again, I'll demo that in a few slides. You can download your report on both tools. However, you can only save a project and return to it later in COMET-Farm when you create an account. You can access the COMET-Farm Cropland accounting activity via an API, which could be useful if you were looking to assess hundreds of thousands of acres of land, which would be tedious on the interface that you'll see during the demo. However, while we have some guiding documents on how to access COMET-Farm through the API, we don't host trainings like this one. So you should be familiar with APIs and how to use them. COMET-Planner, on the other hand, does not have an API, but instead the entire COMET-Planner data set is available for download after you enter just a few details on how you're planning on using it. So I'll provide first a bird's eye view of COMET-Farm before we go into Planner. So as I mentioned before, the descent model, which is briefly outlined within the blue book that I was talking about, is the principal soil carbon and now direct nitrous oxide estimation model used in the tool. I'll also provide an introductory paper in my follow-up email, but essentially it runs simulations about how the crops are grown, about how nitrogen and carbon cycle through the soil and the ecosystem. The model simulates how specific crops are harvested, how the crop residue decomposes, and how carbon fluctuates between different sources and sinks as a result of the physical properties of the soil, like temperature and moisture. In COMET-Farm specifically, we're using the Surgo soil database and PRISM weather data set to drive the model. And all the information driving the model comes from a data set developed from peer-reviewed studies from over 200 sites going back 170 years and is maintained by universities and private corporations. And when we made that switch from the 20 centimeter to 30 centimeter descent model, we also started estimating direct N2O emissions. Previously, they were estimated via the empirical calculations outlined in the blue book. And for version comparison details, you can see the info page on COMET-Farm. As an overview of COMET-Farm, users are only going to see the top portion of this slide, the user interface. Users provide information about specific management practices in their location, and this information is used in combination with historical practice, so before 1980, along with the PRISM climate data and Surgo soil data. This combined with methods and equations from the blue book drive the descent model, and then all of that generates outputs which are returned to the user as results demonstrated in either tabular or graphical reports. Again, we'll see all of this in more detail during our demo. Once all of that info is entered, the tool executes the models and allows users to see how their practice changes could impact carbon and nitrogen in their field. While different practices impact different greenhouse gas fluxes, The results are simplified in terms of metric tons of CO2 equivalent. The DACENT model allows users to see that change. And if you recall back to the infographic of greenhouse gas fluxes, which is on the top right corner of this slide, each category and subsource category on the results page corresponds to an arrow on that infographic. When you extend the greenhouse gas categories into the subsource categories, so expanding N2O to include both direct and indirect sources, a confidence interval is shown, and all estimates except soil carbon changes and direct N2O estimates will be shown. Except soil carbon changes and direct N2O emissions, which should be available in fall of 2023. The uncertainty for available source categories were calculated using Monte Carlo simulation methods, and selecting the small histogram opens a window for more information on those estimates. And that's what you see here. As mentioned earlier, carbon markets use the COMET models through the API, which is a side door entrance to the tool, and is only available for the cropland, pasture, range, orchard, vineyard accounting activity in COMET-Farm. It's designed for large-scale analysis, and API users do need to create a COMET account, but none of your model runs will be saved to that account. The API runs on the Google Cloud, so after the 50 free model runs per day per user, we would need to then start charging a small fee to run more per day. We do have a GitLab repository to help users get started, but there's an understanding, like I mentioned, that if someone were to use the API, they are in fact familiar with APIs because we don't offer trainings like this one. The API requires XML input files where there are example files in the GitLab. Each line in the XML file will match the inputs on the user interface, so it's important to understand the workings of the interface prior to engaging with the API. When a file is run, your outputs will generate an XML output file, where again, the lines are going to match the type of input, the type of outputs on the interface. API users will not generate the tabular or graphical report that users using the interface would. Both the API and interface use the same methods and models defined in the Blue Book and DACENT, but the API requires that XML input and will generate a XML output file. Again, just to reiterate, the API is really designed for rapid bulk processing. So if someone is looking to run thousands upon thousands of acres or tons of different scenarios. So let's take a look now at COMET-Planner. As mentioned in the beginning, the idea behind COMET-Planner was to create a tool that was simpler, easier to use, and could demonstrate the relative benefits of NRCS conservation practices within a given region against baseline data. So you just need to know your location, conservation practice that you'd like to assess, and how many acres that will be applied to. Users are not going to see the following two slides when they interact with COMET-Planner. This is kind of behind the scenes. For the tool, random cropland and grassland points were identified within each of the approximately 230 different agricultural regions in the country, defined by the NRCS as major land resource areas. Crop rotations for each point were constructed from the USDA NASS cropland data layer back in 2008 in every region of the country. Additional survey data like average fertilizer rates for crops by state and average crop planting and harvest data for each state were added and became the baseline for the modeling analysis. On each data point, we then superimpose the conservation practice or practices selected on top of that baseline, and then modeled both through the COMET-Farm API. So that the same methods, models, soil, and weather data is used here as in COMET-Farm. But in this case, all the user needs to do is select a state and a county, select from a class of conservation practices and fixed baselines, enter the acreage that they wish to apply said practice to, and on the fly, COMET-Planner will provide average regional impacts of conservation practice adoption. Then COMET-Planner generates scenario estimates, and these are available for 34 NRCS conservation practices or conservation practice standards within the contiguous US and Hawaii.